solve the system of linear and quadratic equations below. So we have actually a pretty easy way to go with this because we have an expression for y that we can substitute into our quadratic expression and then solve for x. So let's take a look. If we plug negative 2x plus 3 in for y in the first equation, we get 2x squared minus 4 times our equation for y, negative 2x plus 3 equals 22. Now we can expand and try to solve for x. That leaves us with 2x squared plus 8x minus 12 equals 22. If we divide everything by our leading coefficient of 2, we're left with x squared plus 4x minus 6 equals 11. And it doesn't look like this is going to factor easily, so let me try using my completing the square strategy to solve this instead. Let me isolate these two terms on this side, giving me x squared plus 4x equals 11 plus 6 is 17. And I want to take the b over 2 and square that whole value to add to both sides of the equation. 4 over 2 is 2. 2 squared is 4, so I'm going to add 4 to both sides of my equation. That gives me a perfect square trinomial over here. And I'm going to factor that out to give me x plus 2 squared equals 17 plus 4 is 21. Now I can take the square root of both sides. So I'm left with x plus 2 equals plus or minus root 21. So my possible x values are x might equal, at my solution point, negative 2 plus root 21, or x might equal negative 2 minus root 21. I'm not completely done because I want to plug these x values back into my original equation for y to determine the corresponding y coordinates. So at x equals negative 2 plus root 21, y equals negative 2 times the x value, which is negative 2 plus root 21 plus 3, which gives us, if we use distributive property, 4 minus 2 root 21 plus 3, which simplifies out to 7 minus 2 root 21. So my first solution point is negative 2 plus root 21 and 7 minus 2 root 21. It's not the cleanest of coordinates, but I could use a calculator to find out more precisely the decimal value of these coordinate points. Let's see what, based off of our second value for x, solution value of x, what that plugs in and makes y. So we get y equals negative 2 times, x is negative 2 minus root 21 in this case, plus 3. We use distributive property again. We get 4 plus 2 root 21 plus 3. And our second y coordinate is 4 plus 3 is 7 plus 2 root 21. So our second solution point for the system of equations is negative 2 minus root 21. That was the x coordinate. And the y coordinate we just figured out is 7 plus 2 root 21. Again, not a super clean coordinate, but we have two solutions to the system of equations right over here that we figured out by substituting the y into the quadratic equation and then using our completing the square strategy to find that the system had two solution points. And if we wanted a more precise solution point, we could use a calculator to calculate out these root 21 values.